Now in these questions, we need to compare decimals which have a different number of decimal places. So first, we have 0.2 and 0.33. The way to compare decimals is to write out both numbers with the decimal points lined up, and then to write 0 in empty squares. And we can do that because 0.20 is the same as 0.2. All this 0 tells us is that we don't have any hundredths. So now it's easier to compare. We start by comparing the larger place values. So here, both numbers have 0 in the ones, but if we go along to the tenths, we have 2/10 and 3/10. So we know straight away that this number with 3/10, 0.33, is the larger decimal, and we didn't even need to look at the hundredths place value. As soon as we saw that the tenths was larger in this number, we knew which was the larger decimal. Now we have 0.9 and 0.99. So again, we write out both numbers with the decimal points lined up, write 0 in empty squares, and now we compare the larger place values first. So both numbers have 0 ones and 9/10. But 0.9 has 0 hundredths and 0.99 has 9. So 0.99 is the larger decimal. Now we have 0.5 and 0.45. Again, we write the numbers out with the decimal points lined up, and we need to write a 0 in this empty square. Now both numbers have 0 ones, but if we look to the tenths, we have 5 and 4, so we know straight away that the number with 5/10 must be larger, so that's 0.5. And it's easy to get confused on this question, because with 0.45, we have 2 digits after the decimal point. But remember, the first digit always tells us how many tenths we have, and tenths are 10 times larger than hundredths. So it doesn't matter that this number has 5 hundredths, because 0.5 has an extra tenth. Now 0.55 and 0.7. We write the numbers out with the decimal points lined up and write 0 in empty squares. Both numbers have 0 ones, but if we look to the tenths, we have 5 and 7. So we know straight away that this second number with 7/10 is our larger number. So let's think back to this first question. We had 0.2, and we know that the first digit after the decimal point is the tenths digit, so we can show 2/10. Then we had 0.33, so that's 3/10 and 3/100ths, which we can show on our fraction bar. And we can see clearly that 0.33 is the larger decimal because a larger amount of the fraction bar is shaded. We could also show place value counters, so with 0.2 we have 2/10, and with 0.33 we have 3/10 and 3/100ths. Next we had 0.9, so that's 9/10, and 0.99, so that's 9/10 and 9/100ths. We can see that 0.99 is larger, and if we show place value counters, we have 9/10 with 0.9, but 9/10 and 9/100ths with 0.99. Next we had 0.5 and 0.45. So with 0.5 we have 5/10, but with 0.45 we only have 4/10, and although we have 5/100ths, because hundredths are so much smaller than tenths, 0.5 is our larger decimal. Showing place value counters, we have 5/10, and with 0.45 we have 4/10 and 5/100ths. So although we've got more counters, we need to remember that we need 10 hundredths to have the same value as 1/10. So the extra tenth in 0.5 means that it's the larger decimal. Then 0.55, so 5/10ths and 5/100ths, and 0.7, so 7/10ths. We can see that 0.7 is larger. With place value counters, for 0.55 we can show 5/10ths and 5/100ths, and with 0.7 we can show 7/10ths. So, for this first number, because we only have 5/10ths, it doesn't matter how many hundredths we have, 0.7 is our larger decimal. Now we have 7.65 and 7.69. If we write the numbers out, one below the other, with the decimal points lined up, we can see that both have 7 ones, both have 6/10ths, but then when we look at the hundredths, we can see that this number with 9 hundredths must be larger, so that's 7.69. Next, we have 4.71 and 4.69. Both numbers have 4 ones, but if we look at the tenths, we can see that the number with 7/10ths, so 4.71, must be larger, and it doesn't matter that the second number has more hundredths, because tenths are larger than hundredths. Now we have 6.01 and 5.99. So remember, we start by comparing the larger place values, so here that's comparing the ones. In the first number we have 6 ones, and in the second we only have 5, so we know straight away that this first number, 6.01, must be larger. It doesn't matter that with 5.99 we have more tenths and more hundredths, because tenths and hundredths are smaller than ones. Now we have 5.45 and 5.5, so we write out both numbers with the decimal points lined up, but here we need to remember to write 0 in our empty square. Now both numbers have 5 ones, but the first number only has 4/10ths and the second number has 5/10ths, so 5.5 is our larger decimal. We can show what we were comparing with place value counters. So 7.65 is smaller than 7.69 because 7.65 only has 5 hundredths and 7.69 has 9 hundredths. 4.71 is larger than 4.69 because both numbers have 4 ones, but because the first number has 7/10ths, that's larger than any number with only 6/10ths. It doesn't matter that here we have 9 hundredths and here we only have 1, because remember, we need 10 hundredths to make something with the same value as just 1/10. Then we had 6.01 and 5.99. 6.01 is larger because ones are larger than tenths, so it doesn't matter that we've got 9/10ths and 9 hundredths, because even 9/10ths and 9 hundredths taken together have less value than 1 whole. So because this number has more ones, we know straight away that it's our larger number. Finally, we had 5.45 and 5.5. 5.5 is larger because although the first number has 5 hundredths, hundredths are smaller than tenths. We need 10 hundredths to make something with the same value as 1/10. So, because the second number has an extra tenth, we know that 5.5 is the larger number. Thank you so much for watching. I really hope that was helpful. If you're a teacher or a parent, then please subscribe or go to keystage2maths.com to download resources for this lesson and many more. That's all for now. I'll see you in the next video.